Hello everybody, I'm Miss Chanel. Thank you for watching this video. I hope this will be useful. I'll be going through a pattern question today. So I hope this video will help your child. Let's take a look at this. So I believe that we all know that we always have a question for P5 and P6. The last question is always pattern. I'll start with the basic kind of question first. Please follow us, and then you will get to learn more skills on different kind of patterns and all other frequently test PSLE and P5 questions and even out to secondary school questions. So let's begin with the question. So we have this question, we have diagram 1. Basically, what I always tell my student that they have to do is that first thing we start with writing down whatever information that I have here. In this case, each diagram represents table and students. So the rectangle one is equals to the table, and there's like round circles representing the students. So in the first diagram, there's one table, and then there is equals the students is equals to 6. And then for second one, we have two tables, and then for the students, we actually have 10. So the next one here, we have 3 tables, and then our students is equals to 14. So what we need to see to be able to see here is that the linkage between the n term. So n term, some students cannot do the question uh when the number get bigger, like for example for C, because most of them do not know how to use n term. So what they are able to do for this kind of easier question is that they can still see that there is a difference here that is going to be add 4 here, and then for the students here is also add 4 here. So for this kind, we call it constant differences. So for constant differences, right, what we can actually do for the n term is that it's quite easy to find n term. So what do I mean by n term? So normally for n term, what we will actually do is that we'll let the figure number be n. So let the figure number be n. So let figure number be n, or it can be any alphabet. So we have like n. So when n equals to 1, let's say for figure number 1, when n equals to 1, because like the n will be equals to the figure number. Yeah, so what they actually need to know is this one. And then whenever we have a constant change, in this case is 4, we can instantly know that we will have 4n. So if let's say the constant change is 3, so it's like from diagram 1 to diagram 2, the change is plus 3, I will be using 3n. If let's say the 3 continuous for the 2 to 3, diagram 2 to 3 is also plus 3. So in this case, we have 3n because it's plus 4 and then plus 4 for the red one that I just draw on arrow. So we have 4n, and then how do we actually get to know what do we do behind? So normally the behind, we can actually take 4n um, plus something or minus something, but how do we decide what is it supposed to be? We always look at the very first one. So the first one is the indicator. So in this case, my first one, the indicator here tell me say the student is equals to 6. So means here, I will actually get 6 here. So what I will need to know is that 4n actually just means 4, because 4 times 1 for figure 1, it will give me 4 here, and then I need to plus 2, then I get to 6. So my n term, basically, I will have 4n plus 6 plus 2, that equals to 6. We're going to test that out to figure 2 and figure 3 to see whether the n term actually works or not. We need to at least try 3 times, because sometimes it could be a alternate cases. So for figure 2, what we have here is basically 4, and then our n is plus 2. So it will be replaced as 4, replaced with the figure number 2 here, and then we plus 2. So basically I will actually have 10. So it works for this one. So it is correct. So we try the next one for figure 3. So figure 3, what we actually get here is equals to 4 and then bracket 3 and then bracket and then plus back 2, and then I actually do get 14 as well. So this is also okay. So after 2 or 3 tries is okay. So means my equation is confirmed that it's going to be 4n plus 2. So this is the correct n term. So why do we need to actually form n term? So in this question here, as you can see, how many students can be seated if 4 tables are joined together. So let's try. So when 4 tables are joined together, as you can see, the tables, the relationship between the tables here is equals to the green one. So the diagram 1 has 1 table, diagram 2 has 2 tables. So it's quite clear. 3 has 3 tables. So when it is diagram 4, when they ask for the students, so means I just go to figure number 4. Because figure number 4 will have 4 tables, and to find how many students are there for figure number 4, we can easily use our n term of 4 and then bracket 4. When we bracket means we times, so 4 times 4, we plus 2, basically we get 18. But I know some people will tell me, say that, oh, it's actually quite easy, what we can just list it out. Like the next one, I should be just taking 14 plus 4, I can easily get 18, right? Yes, of course, I do know that. But the thing is, like, we have questions like C that we will actually need to know, or we have like question like B that we actually need the n term. So if you look at B, what we actually have here is how many students could be seated if there's 20 tables joined together. So remember my n term just now, it was 4n plus 2. So if I have this, isn't it much easier? Because if there's 20 table means it's diagram 20, meaning that if they are listing, they have to list 20 sets of different numbers, which is going to be very long. Some students even have to draw it. So I do not recommend that. It's better to learn n term. Hope this video will help you all learn. So we have 4. And then when we know that when n, in this case, n equals to 20, because it's 20 tables, I will have 4 times 20 and then plus 2, and then straight away we get our answer, which is 82. And it will also help us with the last question for number patterns, because they will always ask us for what if there's 99 tables, what if there's 99 students, etc. So how do we find it if we don't have n term? You cannot list to 100, right? But if you actually have n term, it's quite easy, right? So we have 4n plus 2 in this case, and then when there's 100 table, when there's 100 table, when there is 100 table, we also know that the table and the figure number is directly linked, right? So it means it is figure number 100. So when it's figure 100, what we have is like 4 times 100, because our n terms in this case is 100, and then we plus 2. So if I plus 2 here, I'll have 402. I do not need to list everything now. And then that's how you actually get for constant difference question. I hope this session helped you all. Thank you. And then please stay tuned to our website. And then if your child actually still need help, can please check out the link at the bottom. We do have poster class as well. Thank you.